Hi, everybody. Let's jump into lesson 23. First, let's start with a couple of vocabulary terms that we're going to see on our interim, and we're going to use these throughout the lesson today. Those vocabulary terms are accept and refute. We use these to talk about whether or not we agree with or reject or disagree with the claim that's made. For example, the rock pocket mice changed their fur color to blend in with the lava. Do we accept or refute that claim? Do we agree with that claim or do we reject that claim? I hope that you decided to refute that claim. We know that an individual organism can't change its physical traits in order to fit in with a change in the environment. Let's go ahead and move into the lesson. What we did last time is we went through lessons 15 through 21 and pulled out the different pieces of natural selection and put them into a nice sequence to understand this process of selection for boldness in the birds of the University of California, San Diego population. What we're going to start looking at now, going into lesson 23 on, is we're going to start looking at what other differences might exist and how does the environment for which the birds decided to stay, how did that environment impact other features of the birds as well? So the question we're asking today is, why did some of the juncos stay in San Diego in the first place instead of migrating back to the mountains with the rest of the juncos? And we've talked about this a little bit in some of the lessons, so some of this will be a little bit of a review. So we're going to be focusing on our timeline. We're focusing over here at 4 or 5. We're going to understand this population that split off from the original population. We're going to try and understand this population a little bit more. What you're going to see in the next slide are two photos. We're going to see a photo from 1953, before the campus was built, and another picture from 2005, about 35 years after. So about 45 years after the campus was built. Here we have Camp Matthews, originally a military base in 1953. We see lots of open spaces, again, lots of green space still, very hilly, not a lot of trees, also not too much human activity, a lot of big open spaces. Let's look at a picture of 2005. Now this picture is going to come in over the top of this picture. It's the same area. Well, let's look for the change. Do you see a difference? I certainly do. I see many more pockets of trees, especially lining roads. I see some parks, lots of green spaces, certainly more roads, and lots of buildings. Definitely, there's been a change in this environment. One thing that we looked at is we looked at what the campus activity looks like during the day and during the night. And you are asked to go through, and what are some things that we notice about the activity level at a college campus, day and night, compared to what it may have been on a military base? So what are some things that we decided? I think we decided that it's much brighter and there is a lot more stuff going on, a lot more human activity, and definitely a different variety of resources that were originally available. So we're going to start to tell the story by looking at data and seeing, how does this new environment, this new urban environment, how might this impact not just necessarily the boldness of the birds, because we know that that was one factor, but what are some other things that may be impacted by this new urban environment? Let's look at climate data. So this is the average precipitation and temperature of San Diego. The green bars, the bar graph, that represents precipitation. And the line graph, that represents average temperature. We look at the bar graph. If I look at the months at which the birds normally nest, which is this late spring and summer, I noticed that May through September, there is less than half an inch of rain in the San Diego area. It's pretty dry. If I was a mother bird and a dad bird, and I was looking for a place to nest and raise young with plenty of resources for food and water, San Diego may not be the place for me. If I'm a bird who doesn't want to be on the cold mountain where there's snow and of course the food is not available and the water is frozen on the mountain, then I definitely think that October through March and into April would be pretty cool months to hang out in the San Diego area. There's a lot more precipitation, can probably find more water and food resources during those months. So, this climate data helps us really understand why the birds were migrating in the first place. During the spring and summer, we go up to the mountains where it's cooler and there's food available, and then come back in the winter when the mountain is too cold, and we come back to the San Diego area where now there is water and food resources available. Now, how might the college campus have changed this resource availability? Well, we've talked about this already. Humans, by putting in things that they like, trees, shrubs, gardens, flowers, grass, that would definitely increase the amount of vegetation that the birds have available to them for food and for habitat. There would also be more insects buzzing around due to due to all of the food and the waste and because of the increased vegetation. And the other piece of it would be more places for nesting. So we know that the college campus definitely would impact the availability of the birds to survive in the San Diego area, even with this type of climate. But there are other things on the college campus. One of the things we talked about in lesson 15 was that there was a lot of light pollution, and it was mentioned just very briefly. So, how can lights affect birds and their decision to migrate and not migrate? Well, this is an example of a graph that was taken back in 2015 on September 11th. September 11th in New York City, they do a tribute in light where they light the memorial for the 9/11. And these lights go way up into the sky, and they're pretty amazing. But one thing that happens is when those lights are on, the birds that are in the area, their migration routes get way messed up. And so what happens is they see these lights and they move towards the light. Now, you've seen this happen with other flying things like insects, maybe at your front porch or when you're camping, and the bugs fly towards the light. Well, birds do the same thing. We can imagine with a very bright college campus that birds like the juncos may be drawn to that bright environment as well and mess up their migration route. But light at night also has some other effects. In fact, there are 3 effects that were studied in a different bird population, but would fit for our juncos as well. 2 of them are connected to each other. Let's talk about those. Testicle width and testosterone levels. So, testicle width is when allows the birds to be ready for breeding and ready for reproduction. If we look at this chart, the red on all 3 of these graphs represents birds that were exposed to light all night long. The graphs in the lines in blue represent birds that were exposed to natural light cycles, natural light and dark. We can see that in the testicle width that the birds who exposed to light all night long, that their testicles start to increase in size much earlier. In fact, as early as February, and they stay larger all the way through May. So we have a 4.5-month window where their testicles are at that size where they are prepped for mating. Whereas the birds with the natural light cycle, they don't get into that level until March and leave in June. If we look over testosterone levels, it's a similar story. The testosterone levels of the birds exposed to light at night Their testosterone levels increase much earlier in the year. They stay higher for a longer period of time before dropping. The other thing is first song before sunrise. Now, birds sing to communicate with one another, to find mates, to claim their territory, and all sorts of reasons. We can see that birds are exposed to light all night, those street lights and car lights and headlights, home lights and porch lights, that from February through June, that they are singing earlier. They're singing before sunrise. In fact, in April and May, they're singing as early as almost 2 hours before the sun starts to rise. Whereas birds on natural light cycles, even in April and May, the earliest they sing is about 40 minutes before sunrise. What does this mean? This tells us that there could possibly be some effects of the environment on these birds. So let's use all of this data to tell a story. If the birds stayed and nested before the campus was built, the birds and their offspring would not have survived in San Diego. Do we accept or refute this claim? We should accept this claim and support it with some evidence. We can use the climate data and the fact that there's very little rain during those nesting reproductive months in the San Diego area. Because if there was no rain, there would be no food and no water to feed their young. And they would not have survived. Let's look at the next two claims. Sometime after the campus was built, some birds did not migrate back to the mountains. They stayed in San Diego instead. Do we accept or refute this claim? We accept this claim. What would be our reason why? The reason why they stayed could be that the light pollution or the amount of light at night in the surrounding in the campus urban environment caused the birds to stay. Our evidence that supports this, of course, is that light data from New York, that tribute in light. Let's look at the third one. Sometime after the campus was built, birds that stayed in San Diego year-round began to reproduce earlier and more often than birds that migrated back to the mountains. One reason that we could accept this claim rather than refute or refuse this claim is looking at testicle width and testosterone levels. That birds that are exposed to light pollution and an urban light environment increase in both testosterone level and testicle width in preparation for mating much earlier and for longer periods of time. As we're thinking ahead into the lesson 23 home learning, there's some other data that helps support this. Given that the University of California, San Diego juncos have 4 times more broods, that means more groups of laying, times of laying, more broods of chicks from eggs every year than the mountain juncos, what are some other behaviors you think may have changed in the University of California, San Diego junco population since it separated from the mountain population? What might be some other behaviors? Maybe some mating behaviors? Maybe some other behaviors that go along with this change. And that's where we're heading next, is that we're going to look at other ways that natural selection has affected the University of California San Diego juncos. Besides brooding 4 times as much and starting much earlier in the year, what are some other possible things that have happened to the University of California San Diego juncos to make them even more different than the original Mount Laguna population?